Let us take this example of you have on the ground. Let's take this example of let's say that you and your friend are in a park, right? And let's say that you are this is you, and this is this is your friend, right? Your friend is actually sitting, right? Your friend is actually sitting on the floor. Um, and consider two scenarios. In one scenario, your friend is sitting on the floor, and in another scenario, your friend is actually on the swing, right? So there is a swing, and here is where your friend is on the swing, right? It's the same person. Your friend. Think about a scenario where your friend is sitting on the floor, as well as your friend is also on the swing. Now, which is for you? Which one is easier for? In which state is it easier for you to push your friend and cause your friend to move, right? If you think close, because your friend is sitting here, and if you try to push your friend here, you're probably going to apply more force for your friend to start moving, right? But here, because your friend is on a swing, right, which means that you don't have to apply as much. It's not going to be as difficult for you to move your friend who's on the swing here, right? So the force that you apply here and the force that you would apply here are going to be different, right? So this let's call it FA, and this is going to be FB. Most likely, this part you're going to apply lesser force here to create to alter the inertia of your friend and cause him or her to move, right? Now, why is that so? The reason is because your friend is sitting on the floor. There is a resistance provided by the floor, right? There is a resistance which acts opposite to this particular force, causing you to apply greater strength to overcome that resistance and get your friend to move, right? So in this case, that resistance is not there. You just need to apply the force and get your friend to move in that swing, right? So there's going to be a resistance here, which is not present in this scenario. Now, in other words, to say, your resistance is actually balancing the force, right? It is actually balancing the force that you're applying here, and that's why your friend doesn't move immediately, right? And to really make your friend move, you have got to overcome that force, that resistance, so that you have to create that unbalanced. You have to create that unbalanced force on your friend to really make him move, right? Which means that your force FA has to be greater than this resistance, which means that unless you create that unbalanced force, your friend is not going to move from the force. Here also, if you see here, there is an unbalanced force that you create because there is no resistance. Whatever force that you create itself is is unbalanced on this particular on your friend here. So your friend immediately begins to move. So the point here is that to really change the velocity of to alter the inertia or to change the velocity of an object that is already in motion, your net unbalanced force, right? Your net unbalanced force has to be non-zero for you to change the velocity of that particular object. To change the velocity of the object, right? So your net unbalanced force has to be non-zero, and until that happens, the velocity of that object will not change. Like here, even if you apply some force, it may not help unless because that will be easily balanced by the resistance, and unless you overcome that resistance and create that imbalance in the force, your friend on the ground is not going to move that easily. Right? So this is something that you've got to remember. Now let's talk about let's talk about a different scenario. Let's take the scenario of let's take the scenario of a sprinter, a runner, right? Let's take what happens the starting point of a race, right? See, a person who's sitting on who's getting ready to start a race. If you really observe, how does a person sprint? How does a person launch him or herself from the ground and start the race? Right? Be it 100 meters or a 200 meters race. If you really watch their feet closely, they would be pushing. They would actually the what you call as the sprinter's launch pad. So they would actually apply a push to and then that is how they will they'll begin their action, right, in the form of they'll begin their run towards the final line, right? And same is the case with if you see swimmers, the way they start the race is they'll jump. It's not that they're just jumping. They'll exert a force on the floor on the launch pad, and then so that they get the maximum distance, they get the maximum lead on their respective track or on their path, right? So, which means that for you to acquire certain amount of force, you got to apply a certain amount of force in the opposite direction. Right? What you in the case of a sprinter, he or she has applied the force on that launch pad. That is how he or she was able to set herself into motion. Right? He was at rest. Unless he had applied that force on that launch pad, he or she wouldn't have started to run. Right? So, which means that. Which gives an interesting property about force, that force always occurs in pairs. In the case of the sprinter, the sprinter applied a force on the launch pad. In return, the launch pad applied that same force on the sprinter, so that the sprinter started to move. Right. So in everything, say if you are the runner and if you are the launch pad, right? The runner applies the force, and in return, the launchpad applies the force back on the runner. Right? So it always occurs in pairs. Any force always occurs in pairs, and we call we call one force as, if we call one force as the action, we call the other force as the reaction. Right? And both acts on each other. Right? The action, this force is applied on the launchpad, but this one is applied back on the runner, right? Now, this is Newton's third law, which is famously told as, for every action, there is an equal and an opposite reaction, right? When you apply some force on an object, that object will in turn, apply that same force, will react by applying the same force back on you, right? So this is Newton's third law. Yeah. So with this, let's stop here, and we'll take this further in our next video.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.